Okay, so everyone's being recorded. All right, now, special segments. Okay, whoever's playing a cartoon, can you please turn it off? Thank you. All right, now, special segments. So we talked about 3 special segments that occur in circles. One is with, well, actually 4 special segments. One where you have 2 chords intersecting within a circle. One where you have a tangent and a secant. Tangent and a secant intersecting at the point of tangency. One where 2 secants intersecting on the outside, and one with a tangent and a secant intersecting on the outside. So let's go over this. So if we have 2 chords intersecting on the inside, the relationship is this piece times the piece next to it is equal to this piece times the piece next to it. So that's with 2 segments intersecting on the inside. The next relationship is when we have 2 secants intersecting on the outside. It's the relationship is the segment from the intersection point to the circle times the entire segment is equal to the part to the circle times the entire segment. Okay, the last relationship is when we have a tangent, and I know it's a tangent because it only intersects the circle at one point, intersecting with a secant, both on the outside. Okay, they're intersecting on the outside. Okay, and the relationship is the tangent squared equals the part to the circle times the entire segment. So the first thing you need to know is the relationship of these 3 special segments, right? And you need to know what you're looking at. Are you looking at intersecting on the inside, intersecting on the outside, and what is being intersected? Now, let's look at a couple of problems. So let's look at number 45. Number 45 says, this piece is x plus 3, this piece is 15, this is x plus 2, and this piece is 19. So the first thing you have to ask yourself is, what are these? What type of lines are these? And these are 2 secants intersecting on the outside. So remember the relationship. This times the whole equals this times the whole. So x plus 3 times the entire segment. Now the entire segment is x plus 3 plus 15, which makes this x plus 18. Equals x plus 2 times x plus 21. Now, the rest of it is just algebra. Pretty ugly algebra, but algebra nonetheless. Okay, so remember, how do we multiply 2 binomials? Okay, you can FOIL or you can do double distribution. So remember, foiling is first, outside, inside last. So if you let's do the left side first. Okay, so the first terms multiplied together gives me x squared. The outside is 18x. The inside is 3x. And the last terms multiplied together is 3 times 18, which is 54. Okay. And if we do the same thing on the right side, it's x squared plus 2x plus 21x plus 42. Now you have to combine like terms. Okay. And basically all you do is solve. Subtract x squared from both sides. Subtract 21x and then subtract 42 from both sides. So the answer is x equals 6. All right. A lot of algebra, not pretty, I understand, but this is just the nature of these situations, right? So that's a problem where I have a two secants intersecting on the outside. Any questions with this problem type? So piece times whole equals piece times whole. Now, let's look at, can I erase this? Is everyone good with this?
Yes, sir.
All right. So now let's look at two lines intersecting on the inside. Okay, so like number 47. So remember the relationship is when it's on the inside, it's piece times piece equals piece times piece. So this is about as easy as it comes, and basically you have to just do the math, okay? So 15 times 12 is what, 30, and 15 is 180. Okay. Then solve x equals 10. All right. Any questions? So does everyone see the difference between the previous problem and this problem? In the previous problem, it was the piece times the whole equals the piece times the whole. Here, it's piece times piece equals piece times piece. And the reason for that is because of where the lines intersect. If it's on the inside, it's piece times piece. If it's on the outside, it's piece times whole. All right, now let's look at number 51. So unlike the other two, this one is a secant times a tangent. And I know it's a tangent because this line, FE, just intersects it at one point. So remember the relationship. It is piece times whole. So 27 times 9x plus 3 plus 27, which is 9x plus 30, equals 36 squared. Okay, equals the tangent squared. Now algebra basically, and not pretty numbers, so let me get out a calculator. Okay, so 27 times 9 equals 243x plus 810, because 27 times 30 is 810. And 36 squared is 1296. Subtract 810 from both sides. Okay. Divide by 243 and we get x equals 2. Now, in this problem, we're not just asked to find x. We have to use what we found for x to figure out, to answer the actual question, which is GH. So GH is 9x plus 3. Well, we just found x to be 2. Okay. Any questions? So we did one of each type. We did one where we have two secants. We did one where we have inside the circle intersection, and we did one with secant times tangent. Okay. Any questions? Anyone want me to work any more of these example types out? This Gaines, you
No,
good?
sir. Hey,
All right.
Mr. Darinati,
Ma'am?
what lesson you on? Like, I mean, cause like I'm on a way different level. I might be farther because I'm on areas of triangles and parallelograms.
Yeah, but somebody said they want me to do special segments, so that's why. I'm going to go to that next, but I just wanted to, somebody wanted me to address the problems with special segments. That's why.
Okay, I'll just make sure I didn't got too far ahead.
No,
So,
you're not, there's no such thing as too far ahead.
okay.
You want to go ahead and get done so that you don't have to worry about me anymore, at least for this year.
Yes, sir.
All right. Okay, Mr. Caleb, you said you had some questions.
Yeah, I already passed the test. I wanted to like finish it now. So I just watched some videos on YouTube and I was able to finish it. But it was mostly problems like number 53. It just, my algebra just kind of got trippy there, but
Yeah. The main thing is the algebra here. So it'll be like this one, remember it's secant times tangent. So it's tangent squared equals piece times whole. Okay. And then you do the algebra. The reason I like this is because, like for you, Mr. Caleb, you're going to be going into algebra 2 with trig. So this definitely helps you practice your foiling. And then solve. And then plug in to find EF. So EF would be 12. Okay. All right. Any questions with these problem types? Are we good? So for those of you who've not finished circles, don't stress out. It doesn't mean you're behind. It just means you need to sort of pick up the pace and get done with it. All right. And if you get done with the area and stuff, then you're done. Once you're done with the next chapter, which is area and dimensions, whatever, I don't know the name of the chapter, I forgot it, but then you're done with geometry, okay? You're finished. So I encourage everyone to sort of hammer it out as quickly as possible. All right, so let's look at those files, by the way. Let's look at the area of a triangle and stuff. Let me figure out where I put it. All right. Okay. So in order to do these problems, the first thing you need to know is your distance formula. Okay, your distance formula. So you need to know how to work with your distance formula. And we've been working with distance formula throughout the whole year, so you should have a good practice underneath your belt with the distance formula, right? And with this, you also will need to know what the area formulas for a triangle and a parallelogram are. So a couple of things that you need to remember. First of all, get a piece of paper here. The area of a triangle, and I know many of you probably know this, is 1/2 base times height. Now, this is the key thing to remember. You just can't pick any number to be the base and any number to be the height. The key thing to remember when you calculate area of a triangle is the height is perpendicular to a side, okay? So the height is a line that is perpendicular. And the base is the line that it is perpendicular to. So if this was the diagram, this would be the height, this would be the base. Right? So the take-home point, even for parallelograms, is you need to identify the correct height and the correct base. You just cannot willy-nilly pick two sides. The height is always a line perpendicular, and the base is always the line that the height is perpendicular to. Right? Now, for example, what would be my base and my height in this diagram?
Wouldn't your base be 12?
No, your base would not be 12.
Oh.
What did I just say? The base is not always the bottom number.
Base with 9, height with 7.
Right, the base is 9 and the height is 7. So Mr. Caleb, can you explain why you chose those two numbers and not the other ones?
The 90-degree angle.
Right, because remember the height has to be perpendicular to something. So the height is the line that is perpendicular. So the only line that is perpendicular is the one that is 7 units. And the base is what that line is perpendicular to, so 9. Ms. Gaines, do you see that?
Sir?
Do you see that? You see why we picked those numbers?
Yes, sir.
Okay. So again, height has to be a line that's perpendicular. The base is the line that the height is perpendicular to. Now, sometimes with obtuse triangles, remember an obtuse triangle is a triangle whose largest angle is more than 90 degrees. The height may be the line on the outside, okay? Now, another thing with these types of triangles, okay? The height is 11. It's a line that's perpendicular, okay? And the base is not 8. The base is only the part of the triangle that the height is perpendicular to. So the base would be 5, okay? Because the base is this piece right here. This piece right here. So this is perpendicular to this base, okay? This part of the triangle, okay? This part is not part of the triangle, so this is not part of the base. And this is not the part of the triangle, so this is not the base. So the height is this, and this would be your base, 5. Okay. So let's do a problem type. Okay, calculate the area of this triangle, please. Calculate the area of this triangle.
$10.5.
How did you get 10.5?
Wait, I did it wrong.
Yeah, that's not right. So
28.
how'd you get 28? Tell me, what is your base? What is
7.
7 was what?
Base is 8 and the height is 7.
Right. So the base is this part of the triangle. And if the whole thing is 11 and this piece is 3, that means the base is 8 and the height is what's perpendicular. So 7. Okay. Good. Right. Any questions? Now, something to remember. Now, with a parallelogram, the formula for a parallelogram, for all parallelograms, is base times height. Okay, so a triangle is 1/2 base times height because it's half a parallelogram. Okay, so if the triangle is 1/2 base times height and it's half a parallelogram, the entire parallelogram would just be base times height. Now, and nobody has a problem calculating the area if I gave you a rectangle. Okay, most of you probably could do this when you were like in what, 2nd grade? Okay. The area of this would be 30. I know it doesn't look like a rectangle, but I'm drawing really fast, right? But not all parallelograms are rectangles, and we've had this discussion before. Most parallelograms actually look something like this. Okay. Now, let's put some numbers on the board here. 4 and say 6. Okay. 4 and 6. Now, there's a problem. You can't say base is 6 and height is 4. Okay. You can't do that. Just like with triangles, the height is a line that is perpendicular, and the base is the line that the height is perpendicular to. So, this would be the height, okay? So if you're given a diagram like this, the base would be 6 and the height would be 5, which makes the area 30. Sometimes the height will be given in this diagram, okay? And others, you might get this type of depiction. Okay. Same thing, the height is 5 and the base is 6. Now, notice, this can also be the height. If I gave you a diagram like this, okay. Now, in this diagram, the base is 4 and the height is 7.5. Okay. Height 7.5 because that's the line that's perpendicular. Base is 4 because that's the side that the height is perpendicular to. Okay. Now, what if I gave you a diagram like this? And I asked you to find the area of this the area of this parallelogram. Does anyone have an idea how to do this? So what would be my base here?
6?
6 would be the base. So what is my height?
Don't know.
Okay, so this is my height, right? And I don't know the length of it. Well, if this piece is 3, what is this piece going to be?
3, right?
3. Okay. So what am I dealing with here? What type of shape is this?
Parallelogram. Well, that's a
What is this?
that's a triangle.
What type of triangle? What type of triangle?
Wait a minute. I know this. Wait.
Right triangle.
Right triangle. What's the relationship of the 3 sides of a right triangle?
They're all congruent, right?
No, 3 sides of a right triangle are not always congruent. That's an
A
equal.
squared plus B squared equals
Yes.
C squared.
What do we call that theorem?
Man, I forgot all about that.
Pythagorean theorem.
Pythagorean theorem.
I forgot all
I
about
got
the
too much time
Pythagorean
on my
theorem.
hands.
So remember, these are the legs, and this is the hypotenuse.
Gosh, I can't believe I forgot all about the Pythagorean theorem.
Can't forget that. That's like one of the key things of geometry. Okay. So what is C in this triangle? What's the length of C? Mr. Caleb, what's C? What's my hypotenuse for that triangle?
It's one of the legs.
No, C is not a leg, it's the hypotenuse. Which one is the hypotenuse? Which one of these 2 measures is the
It's
hypotenuse?
5.
It's 5. And the leg is, one of the legs is 3.
3.
So we can use the Pythagorean theorem to find the other leg, which is, by the way, my height. Okay. So now that I know my height is 4, then my area is 24. Okay. So there are problems that you'll have like that. Okay. Let's do another one. Okay, find the area. Find the area. All right. So what would be my base here? What number would be the base?
Base of what? The parallelogram or the
Mhm.
7?
Okay, good. Now, how would I get my height?
Pythagorean theorem thing.
Mhm. So Pythagorean theorem, I need to know one of the legs, and I need to know the hypotenuse. So what's my hypotenuse? What's the hypotenuse of this right triangle?
$13.
Okay. And what would the leg be?
5.
Okay. Because if this whole thing is 7, this part is 5. Okay. So now you plug it in. 5 squared plus the height squared equals 13 squared. So 25 plus height squared equals 169. Height squared, subtract 25 from both sides, get 144. Square root both sides and get height is 12. So that makes my area 84. Any questions? Now, on Edgenuity, you may be given problems that have these same shapes, but they're on a coordinate plane. And if you have it on a coordinate plane, then all you really have to do is use the distance formula to find your bases and heights. Okay. That's how you find the length of a side on a coordinate plane. You use the distance formula between the 2 points. Now, last problem type. What's the area of this triangle? The area of this triangle. So remember, for triangle, it's 1/2 base times height. What is my base? What's the length of my base here? Well, what's the base? Which one of these numbers is my base? Eight. Okay, well, you got 9 fingers up at 8. Okay. Now, remember, 17 is not the height because 17 is not perpendicular. This thing is my height. Well, it's a right triangle. So how can I use the relationship that I know about right triangles or sides of right triangle to find the height? Well, Pythagorean theorem. And when you do the Pythagorean theorem, one of your legs is 8, your hypotenuse is 17. You calculate the height and you'll get 15. Then so once you find that this is 15, plug it in. Get the area is 70. So take home point about area of triangles and parallelograms. Triangle is 1/2 base times height. Parallelogram is double that, so it's just base times height. take-home point is the height has to be perpendicular to the base. You just can't use any two numbers, or you just can't use the bottom number for the base. The height is the line that is perpendicular. The base is the line, is the side that is perpendicular to the height. Okay. Now, that may mean that you may have to use the Pythagorean theorem and your relationship with right triangles to find the height, because most of the time, some of the times, the height may not be given to you. And the last thing is, if you have these types of shapes on the coordinate plane, to find the length of any sides, you have to find the distance between these 2 points, which means you're going to need to use the distance formula. Okay. Any questions? Okay. All right, well, finish up. This section should be a lot easier than circles because it's just a bunch of formula problems. And yeah, if we have no questions, then we can call it a day. All right, so if there's no more questions, then I wish you good luck, and I will see you guys tomorrow. Have a nice day.
You too, Mr.
Bye.
Mm-hmm.
Okay, Mr. D.
Oh. Yeah, that I made a mistake. Somebody pointed that out. 4 times 15 is not 70, it's 60. I never said I knew how to do math. So, oh well. I'm way overpaid for what I know how to do, trust me. Y'all have a nice day.